In this video, we're going to derive the divisibility rule for 3. Note the following. Note that 3 goes into any number that has a sequence of 9. That is, 3 divides 9, 3 divides 99, 3 goes evenly into 999, 3 goes in evenly into 9,999, 3 divides this number, 99,500, and of course it does, because no matter how many 9s you have, 3 goes into 9 3 times, 3 goes into that 9 3 times, 3 goes into all of those 9s 3 times, and 3 goes into 9 3 times. The answer is just going to be a sequence of 3s. 3 goes into any number that is just 9s. Any integer that's either 9 or 99 or 999, etc. Okay. So, let k be the following integer. A sub n 10 to the n plus a sub n minus 1 times 10 to the n minus 1 all the way down to a1 times 10 plus a sub 0. Now, I guess let me move this down a little bit. And let me write a second note. Note number 2. 10 to the n minus 1 is let me just write it a little bit differently. 10 to the n is a sequence of 9s plus 1. Because if you have 9s and you add 1, you get 10, and 1 plus 9 is 10, carry the 1, another 10, another 10, and then 10. You get 10 to a power. And this statement is for n equal to 0, 1, 2, forever. Okay. So now, let's look at this. This is equal to a sub n times 10 to the n. But 10 to the n is a sequence of 9s plus 1, plus this term, a sub n minus 1 times 10 to a power, which is a sequence of 9s plus 1. 1 less 9 than this one had. All the way down to a sub 1 times 10, which is 9 plus 1. And then plus a sub 0. Now, I'm just going to write this in a different order. This is 999 times an plus 999, number of 9s, times an minus 1, all the way down to 9 times a1, plus, so far, I've just found out what that is. Well, now I need to distribute to the 1s. Need to distribute, to the 1. And realize that I haven't dealt with a sub 0 yet. Okay, so plus a sub n plus a sub n minus 1 plus all the way down to A1 plus A0. Okay. Now, we know that this here, well, let me not say that yet. Sorry. I'll say it in a moment. This number is a multiple of 3. So you multiply it by A1, it's still a multiple of 3. So multiple of 3. This number is a multiple of 3. Multiply it by some other digit, is still a multiple of 3. For example, 27 is a multiple of 3. Multiply it by 5, it's still a multiple of 3. Because this is 3 times 9 times 5. This is 3 times, 45. It's a multiple of 3. 3 goes into this number. 3 goes into 27 times 5. Why? Not because 3 goes into 5, but 3 goes into 27. 9 times. So 3 goes into 27 times 3, 45 times. Okay, so each of those summons are a multiple of 3. This is a multiple of 3. All the way down to here is a multiple of 3. Imagine there is a $3 bill. Okay, this is a $3 bill. And you have many of them. And somebody gives you some more $3 bills. And then some more $3 bills. Well, of course, the whole result will be a multiple of 3. You're going to have many $3 bills. Now, this sum, this plus this, is K. Now, 3 divides K if and only if 3 divides this number. Why? Because we know 3 divides this number, so the only way 3 divides this sum is if 3 divides that number. If 3 goes into A plus B, that means 3 goes into A. Maybe C times. The only way 3 is going to go into the sum is if 3 also goes into B. You have 27 plus 4 divided by 3. Yep, 3 goes into 27. Oh no, 3 doesn't go into 4. Okay, but if I made it 42, 3 goes in there 14 times, and 3 goes into that sum 23 times. If 3 goes into the first number, the only way 3 is going to go into the sum is if 3 also goes into the second number. But it turns out that this second number is just the sum of the digits. It's this number plus that number plus that number plus that number. It's just the sum of the digits. 3 divides this integer k if and only if 3 divides this, which is the sum of the digits. And that is the proof for the divisibility rule for the digit 3, the integer 3. If you like videos like this, please subscribe to my channel. Tell your friends and family and enemies and schoolmates and teachers all about this YouTube channel. Subscribe if you like it. Most of all, watch and learn.